again.
Oh, okay. So you're kind of done with new material, I gather?
I'm not sure. We're just.
Well,
I'm not.
chapter 12, which is on surface areas and volumes of solids, is the last chapter in that book.
12 was the one we were just on.
What's that?
12 was the one we just finished. I don't know. Like we might have skipped around a little bit. I'm not sure.
That's true. It seems like you might have skipped circles, but I can't imagine that you would have skipped circles. And the fact that they're reviewing trig now would indicate to me that wow, it's pretty early. What do you have, like a month and a half of school left?
Yeah.
It's a little early to be ending new material.
Oh wow, that's really weird to think about. That I only have a month and a half of school left. Wow. That's really weird to think about.
Well, we're getting close to that period of time where a lot of my students don't do new material anymore. Is all they do is review for finals. So when you get to that point and the teacher starts giving you material to review, by all means send it to me.
Yeah, we'll do.
Okay. As far as today goes, what kind of trig have you been reviewing?
Just basic SOHCAHTOA. Sine, cosine, tangent.
In other words, just being able to figure out what each of those is, huh?
Yep.
So what's the sine of theta?
Sine of theta is 3 over 5.
Cosine of theta?
Cosine of theta is 4 over 5.
And tangent of theta?
3 over 4.
Cosecant of theta?
Cosecant.
Have they taught you those three, the cosecant, the secant, and the cotangent?
No, they haven't.
Well, they're basically reciprocals. In other words, sine is 1 over cosecant. Cosine is 1 over secant. Notice there's an S and a C in both of these, and just in reverse order. And tangent is 1 over cotangent. So cosecant would be 1 over sine. Well, if sine was 3 over 5, what is cosecant?
Sorry, I'm confused.
Okay. One of these, the cosecant is the reciprocal of the sine.
Oh.
Whatever the sine is, just flip it. If the sine is 3 over 5, cosecant is 5 over 3.
Okay.
In other words, because that is true, then this must be true also. In other words, if one is the reciprocal of the other, then vice versa is true also. So cosecant is 1 over sine, which is 1 over 3 over 5, which is 5 over 3. Now, if you haven't had any of these other three, we probably shouldn't even talk about them. I don't want to give you more information than you're quite ready for. And you'll get a little bit of trig in Algebra 2, and then you'll probably take a full course in trig the next year. You're a sophomore, right?
Yeah.
So as a junior, you'll take Algebra 2, and then as a senior, you'll either take precalc trig or you'll take something like college algebra. I'd like to see you take precalc trig as a senior myself. Only because that's the path towards STEM subjects in college.
Mm-hmm.
Whereas if you take college algebra or probability and statistics, that's not the path. In other words, if you decide you want to go into a math specialty, you want to have precalc and trig on your resume in high school.
Yeah.
So keep that in mind when you have to make a choice. You're not going to get any choice next year. Algebra 2 is the only thing to take after geometry.
Yeah.
But as I've said to you, you have good math skills. You do. And you should be aware of that. And you should be aware that you might want to go into something like engineering. And I don't say that to all my students, trust me. There's only some of them that I think should go into one of the STEM subjects. But you're definitely one of them. So what other kinds of trig are they, other than SOHCAHTOA? I mean, that's pretty straightforward.
That's the only one we've gone over so far, but we've just like started going back into trig today.
You done any inverse trig?
Where you find the angles.
Right.
Yeah.
Okay, let's talk about that. What's the inverse sine, or you can call that arc sine, same thing. What's the inverse sine of 1/2?
Inverse sine of 1/2.
Well, I tell you, I'm not going to use this triangle. I'll change this triangle to a 30-60, and I will label it. Now, one very important concept that you need to know. You take trig functions of angles to get ratios. Notice that the sine of 30 degrees is 1/2. All trig functions end up as ratios.
Okay.
Okay?
Yeah.
You take inverse sines of ratios to get angles. If you want to find the angle where the sine of that angle is equal to 1/2, well, clearly that's going to be 30 degrees. Right?
Yeah.
This is an if and only if. If you remember your geometry, if the sine of 30 degrees is equal to 1/2, then by definition, if and only if, that is true if the inverse sine of 1/2 is equal to 30 degrees. And it's always like that. In other words, no matter the right triangle. Let me give you a different right triangle. You have a calculator in front of you?
I can get one up just on my backpack.
Yeah, go ahead and get one. What kind of calculator do you have?
Or TI Inspire.
Okay, that's good. That actually gives you a little more choices than the TI-84 does. You have it?
Yep.
Okay, you're very familiar with the 3-4-5 right triangle, right?
Yeah.
However, probably what you have no idea about is what the angle opposite the side of 3 is equal to. Nobody does. Nobody knows that angle. Because that's not what's critical about the 3-4-5 triangle. It's the first perfect Pythagorean right triangle. But nobody knows what that angle is. So, if I wanted to solve for that angle, it would be the inverse sine of what?
The inverse sine of 3/5, right?
Correct. going to take inverse sine of ratios to come up with the angle. So in your TI Inspire, make sure, well, it doesn't really matter. Hit the trig key.
Yes. I did
And choose inverse sine. Then put either 3 over 5 or 0.6.
I got 38.6.86.
Got what?
36.86 is the.
Okay. Theta is equal to 36.8. Correct. I round it off typically. That's a 37-degree angle. That's a 53-degree angle. Okay? So, even though nobody has told you about that angle, we have been able to solve for it based on the sides. So, finding inverse is just the reciprocal, or rather it's the inverse process of finding the ratios. In other words, if you could easily tell me all 6 trig functions of theta, but solving for theta, what other function, in other words, how else could I solve for theta? What else is theta equal to?
It's equal to 3 over 4 and 4 over 5.
Well, give me the inverse trig function. It's not equal to 3 over 4.
Tangent of 3 over 4.
Right, it's equal to the inverse tangent of 3 over 4, or it's equal to the inverse cosine of 4 over 5, and I could go on and on. It's also equal to the inverse secant of 5 over 4, because secant is the reciprocal of cosine. All right, I'm trying to think of what they might give you next. In other words, in geometry, they give you a very limited amount of trig. In algebra 2, you'll get a little bit more. And then you'll get the full trig course if you take it as a senior. But how much trig they give you along the way, I'm not super clear on that. Can you help me at all? What did they, in other words, I know that they just restarted it today. Trying to think of what else they could be giving you.
I guess like the chapter's called like property of trig of sine and cosine.
Okay. Notice something here. This triangle. The sine of theta is always the same, even if I draw the triangle out to there.
Mm-hmm.
No longer 3, and that's no longer 5, but and that's no longer 4, but the ratios are always the same. In other words, maybe that's 6 and maybe that's 10. It doesn't matter, but the one thing we know is that the sine of theta is always going to be 6/10 if theta is 37 degrees.
Mm-hmm.
And this is a key concept in trig, is that as this triangle expands, gets bigger, this side gets bigger, but so does this side. And their ratio stays the same. And that's the key fundamental thing of trig. It doesn't matter how much you extend the triangle, as long as it's a similar triangle. In other words, this triangle here is similar to your 3, 4, 5. Only it's a 6, 8, 10. Okay? But theta is the same in either case. We know that similar triangles have same angles, right?
Mm-hmm.
In other words, as long as this triangle is similar to this triangle, all 3 angles are the same. That's the definition of similarity. So whether it's 6 over 10 or 3 over 5, the sine of 37 degrees is always going to be 3 over 5, no matter the size of the triangle. So what you end up with is those are all unique numbers. And in fact, when I was in high school, before they had calculators, they didn't come out with calculators until I got to college. But when I was in high school, they had a table at the end of every math book that gave you all the trig functions of every angle. They would give you sine of 1 degree equals this, sine of 2 degree equals this, sine of 3 degrees equal this.
You can still give out trig tables for trig
What's
students.
that?
I think they still use trig tables for trig students.
No, I don't think so, because
I think so, because
all calculators now take the place of those tables. In other words, you don't need a table anymore if you have a calculator, because a calculator, you can put in the sine of 37 degrees and it'll give you the answer. So there's no real reason to have a table in a book anymore. A calculator was a big improvement of it. And they stopped printing books that had tables in them. There's no need for them, as long as you have a calculator. The only thing I'm really trying to point out is that's always the same number. And it doesn't matter whether the triangle is like that or like that. As you reduce the size of the triangle, the ratio of the opposite side over the hypotenuse always stays at 3/5.
right.
See if I can think of something else that would be helpful to you in trig. You haven't done anything with the unit circle yet?
No.
But they have talked about inverse trig function.
Yeah. We went over that when we first did trig.
What is the inverse tangent of 4/5?
$38.6.
53 degrees.
Oh. Oh, okay.
Excuse me. My mistake.
I didn't see.
Well, I messed it up. What's the inverse tangent of 4/3? And don't use your calculator, use this figure.
3 degrees.
53 degrees. In other words, we're talking about that angle right there. Notice that this is only true if the tangent of 53 degrees is equal to 4/3. Very important that you understand the relationship between a trig function and an inverse trig function. In other words, this is the first thing we can figure out by looking at our triangle, that the tangent of 53 degrees is 4/3. And that's how we solve that problem, is we figure out, well, what angle is it? It's this angle right there. It's not this angle. It's the 53 degree angle that the tangent is equal to 4/3. And therefore, the inverse tangent of 4/3 is equal to 53 degrees. So, I'm guessing that you're going to do a little bit of trig, and then you're going to review for a month. Tell me the surface area of this cone.
It would be 5 pi squared times 10 divided by 3.
Okay.
Or 1
You meant 5 squared pi, right?
5 squared pi.
Right. So it's 25 pi is the area of the base. Plus what?
Oh, I didn't say plus, times 10.
Actually, it is a plus. In other words, the surface
Surface area. Okay.
surface area is much harder than volume.
I forgot about
Volume is the area of the base times the height divided by 3, right?
Mm-hmm.
So volume would be 25 pi times 10 divided by 3. Surface area is much harder. Surface area, you need to figure out the area of the base, which is 25 pi. But then you need to figure out the lateral surface area of that part right there. And the way I've laid this out, what is that hypotenuse equal to? Square root of what?
Square root of 5 squared plus 10 squared.
So square root of 125. And that's lambda. And the surface area of a cone is defined in terms of this lateral measurement. Not the height, but the lateral measurement. And it's pi r lambda. So the surface area is 25 pi plus 5 pi times root 125. And you can reduce that. Obviously, I can reduce root 125 and simplify it. But surface areas are much harder than volumes. Volumes is a piece of cake. Volumes is 1/3 the area of the base times the height. Mm-hmm. No lateral measurement involved. But when you have things like cones or pyramids, surface areas turn out to be a function of lambda. That's a Greek letter. And it means that lateral distance, not the vertical distance, but the lateral, the side distance. All right. Well, I'm sure that by next Monday you'll have some more trig to go over. Mm-hmm. So, either send me something in advance or during our session or something that reflects what you've gone over this last or the next week.
Yeah, we'll do.
Okay? All right, Cole. Have a good one. I'll talk to you next week.
You too.